All right, so we have looked at simplifying radicals. Now we're going to look at our main operations, multiplying, dividing, and subtracting. And we know, same as the product property of radicals, we can also do the same thing with quotient. We can take the nth root of the top and the nth root of the bottom. And what we do is we want to rationalize that denominator by finding something so that I can make this a perfect square root. Well, let's look at a couple here. So I know that since this is, I can rewrite this as square root of y to the 8th and the square root of x to the 7th. But if I wanted to take the square root of the bottom, I would get 3 square root of x. And I don't want a square root on the bottom. So what I'm going to do is multiply this by a square root so that 2 can go into the power evenly. I need one more x to make that, so I would multiply this by the square root of x. Whatever I do at the bottom, I do at the top, so I'm really just multiplying by 1. So then that gives me the square root of y to the 8th x over the square root of x to the 8th. Now we'll simplify both the top and the bottom. So the square root of y to the 8th is y to the 4th. I can't do the square root of x because I can't divide 2 into 1. I can, but we don't want decimals. And then 8 divided by 2 is, so this becomes x to the 4th. So here we know cube root is looking for groups of 3 things. So we can break this into the cube root of the top and the bottom. We're not going to simplify yet. We're just looking down here. This 9 is 2 3s, and I need 3 3s to make that an even. So we're trying to get rid of that radical. It's always our first thing that we want to do. So we know we're going to need one more 3, so we're going to go ahead and multiply top and bottom by the cubed root of one more 3, so we can get another 3 down here. And then this x is 1x, and we need 3 x's to take the cubed root, so we need 2 more x's. So again, we're multiplying by 1, so we haven't changed there. We can multiply these because they're both cubed root, so we do cubed root of 6x squared over the cubed root of 27 x cubed. And if I did that right, this should come out evenly as 3x. And the cubed root of 6, I don't have 3 of anything. When I factor 6, I get 2 and 3, so I don't have any cubes there, and x squared. Right, so that's division, and doing what we call rationalizing the denominator. Let's talk a little bit about this simplifying, and we've kind of looked at this a little. We want the index n as small as possible. We don't want any factors that are the nth power that higher, where the nth power is higher than the n of the index, and we don't want fractions or radicals in the denominator. So let's look at multiplying. We kind of looked at this the other day, but remember when we multiply, we can multiply the outside, and we can only multiply like radicals. So this is a cubed root and a cubed root, so we can multiply this. So 5 times 1 is 5, and then we have our cubed root. 100 times 10 is 1,000, a cubed. And then we'll go ahead and simplify. So 1,000 can be written as 10 cubed, a cubed. Remember, our product rule says we can take the cubed root of 10 cubed and the cubed root of a cubed. So cubed root of 10 cubed would just be 10, and the cubed root of a cubed would just be a. And then go ahead and multiply that, and we get 50a. We're going to keep going just so that we don't get, so this video doesn't get too long. But if you have questions, you can rewind or go back, or we can always go through that problem together if you want. So adding and subtracting is a little bit different because before with multiplying and dividing we multiply and then simplify. Here we're going to simplify first because right now the only way you can add radicals is you can add like radicals, kind of like how we do with x. Like with 3x I can only add that with like another x term. Same thing with radicals. I can only add a square root of 45 with a square root of 45. And I don't see any of those match. So let's go ahead and break or simplify these. So 45, we get a pair of 3's, so they go out with this 3, and I can rewrite this as 9 square root of 5. Same thing with 80. So we have 2 squares, or 2 to the 4th, so that gives me 4 times 5 is negative 20 square root of 5, and then go ahead and do your 20. So you have a pair of 2's, so it goes out with their 4, 8 square root of 5. So now I see these are all square root of 5, so I can add them together. I have 9 square root of 5 minus 20 squares of 5 plus 8 square root of 5. So I want to get a total of how many square root of 5's I have. So 9 minus 20 is negative 11 plus 8 is negative 3 square root of 5. Okay, let's break this down. So we know this is 25 times 3. 25 square root is 5, so 15 square root of 3. This is 16 times 3, so square root of 16 is 4, so negative 8 square root of 3 plus 1 square root of 3. So I put that 15 minus 8, 7 plus 1 is 8 square root of 3. So that is our basic operations: add, subtract, multiply, or multiplying when monomials, one terms. Now let's look at here. This is similar to if I had x plus 5. I can't add these two together, so I can just multiply. I'm going to multiply both terms, so double distribute by 3, and both terms by square root of 3. So we know how to multiply. Now I'm just going to use that. So 3 times 2 square root of 3 would be 6 square root of 3. 3 times 3 square root of 5 would be 9 square root of 5. Negative 3, or square root of 3 times 2 would be negative 2 square root of 9. Negative 3 times the square root of 3 square root of 5 would be negative 3 square root of 15. Then we can simplify. So we have 6 square root of 3 plus 9 square root of 3, 5. This simplifies to negative 6 minus 3 square root of 15. And since these can't be simplified at all, that is just our answer. All right. If you have questions, make sure you get a hold of me.